My name is Anshuman, and I'm working as a machine learning engineer at FreshWorks. And today I'll be presenting that how generative AI can help chat agents for providing them real-time support to doing their job better and also enhancing customer satisfaction. Uh, the brief agenda, I'll be talking about uh, like introducing the concept of like AI-driven language and enhancement real time. What are the scaling or actually like economic obstacles in achieving this in real time? I'll be taking deep dives into few of the features which are built into this product. And moving along, so basically the predecessor to this product was actually we built a post-resolution quality score for millions of chats as they're getting closed, as they're getting resolved on a rubric or metric which was developed by product that, okay, how relevant the agent was answering customer's question, what was the customer sentiment in the end, basically what was the timeliness from language perspective, how was the tone, was there negativity or usage of any filler words, abusive and stuff like that. Doing this for like few weeks, suddenly a idea popped out that why don't we do this in the real time also? Because as we are like scoring like thousands of these agents, after the fact, why don't we do that evaluation real time, kind of like flagging as well as helping them guiding to the corrective actions, apart from like dinging their overall performance after the fact, after the month when we are comparing all the agents with each other. So yeah, so begin with this idea was like, as the agents are typing, like doing like a real-time quality analysis of what they are typing. The step 2 was actually like giving them corrective actions, which is for them to either take it or leave it, and improving like overall relevance, how agents are answering customers' questions, kind of like what we say in standing in this podium that did I answer your question properly, something like that, where giving that kind of notion to agents that whether did they answered or what kind of issue the customers was facing, did they either provided the right explanation if they can't solve the problem and stuff like that. And overall the end objective was to improving new agents as they're getting onboarded, but also improving customer satisfaction. So this is a product mockup, and as the agent is like typing all the utterances, like all of these pop-outs are like regarding their tone, their relevance, their overall language, whether they are using any abusive words, grammar, spelling. And these pop-ups are there to grab agents' attention in real time, less than a second. And then the next step would be to, so sorry, I just jumped one slide ahead. So this slide talks about like as the agent is typing, all of these like flags will pop out, like telling whether a tone needs correction, whether there's a profanity, whether there's a relevance issue, whether like a tone needs correction, whether a grammar needs to be corrected. The second step is actually like the software is supposed to provide all the corrective actions that when they press on the rephrase or when they press on correcting the spelling or the grammar or tone, it will actually give them the corrective response or corrected response, and then it's up to the agent to take it or leave it. A very critical point is that among like all the changes are getting done, we cannot just use paraphrasing or rephrasing at all. The whole idea was that to maintain the original information as is, but to like kind of like correct it to a limit that the original agent's idea is still there, but we are providing like the corrective utterances to the agent. So just to talk about like scalability from like real-time deployment perspective, like I'm talking about like across like 100,000 agents, across 5,000 different like B2B customers, 33 million chats and 64 million interactions. But beneath that, what the number is really matters is that what are the requests per second, the demand which we are looking during the peak demand hours in the week. And given the 95th percentile latency of the model, how many nodes of GPU we are talking about, how much dollars that is per month, and then how much dollars per agent we can charge. And if that is beyond the spec of our product or finance teams, everything goes off the board and we come back to the square one and redevelop the model until we achieve the quality as well as the latency. So latency was the biggest challenge because this is not something that a user can wait for 5 seconds, 10 seconds. He has like 2 hours to respond something. Versus this is like when you go online and chat with a traveling company or a food delivery company, we need response then and there only. So the first part was to detect and correct agent's tone. And when we started, I remember like a product came up with a spec of like good and bad tones, but different LLMs, OpenAI ones or the open source ones, they all have discrepancies among them to an extent that the model output was getting like disputed, not only among like ML team, but within the product team. That doesn't sound rude. That doesn't sound defensive. That is something an agent is usually supposed to do. So immediately we switched the focus for developing like a supervised model where we have a lot more control over each and every bad tone which we define that's saying this is a bad from a customer service perspective industry. And then the step 2 will be to provide a corrective action. So the next step was to build a supervised model. We need a data. 3 months ago or now even, there's not a lot of publicly available data set, although there's a lot in Hugging Face and other domains, but not a lot from like a customer service perspective industry that like a lot of examples of like bad tone or the good tone. So what we ended up doing is that we use large language models to generate a lot of artificial or fake data of what is a bad tone, and then generating like a good tone, and then use this model or use this data set to train the model V0. Now once that V0 model is trained, that is actually run through millions of chat data what we have, and that is mostly getting evaluated from product teams, QA teams, from us, and then all the misclassified examples, the real examples are getting added to the fake or artificial data. That this is something, it's not defensive, this is like saying the things as is, and this is something not should be classified as a bad tone. And then this model iteration really helped to improve the model quality. And again, a lot of work had been done to improve the real-time execution and usage of multilingual embeddings really helped it to be deployed to like multiple languages across the globe. Few challenges which we face along the lines were that, number one, sometimes like what is rude can be sarcastic, and there might be a lot of overlap between these bad tones. So like how to separate them together in a multi-class setup was a challenge. And two, as I said, like even like sometimes if something like obviously very bad, it's very obvious to flag, but sometimes like the borderline cases had a lot of discrepancies. So this model has to do a lot of like a revision and iteration to get an improved response. But all of this started with developing, since we were relying on LLMs to generate the fake data for us because of scarcity of open source available data, this was the first step where we worked with product to come up with the main metrics where we say that these are bad tones. The step 2 is not highlighted in this slide, just to remove a lot of words, is that what do we mean by defensive? What do we mean by argumentative? Like when we read HR policies, it's very well defined. Something like that, like behind the scenes, it was very well defined that if somebody is stating that we have having a IT issue and that's why we can't issue a refund, that might not be a defensive, that's like a real life situation. So a lot of work had been done to define like an annotation rules, and the same annotation rules would have been given to a human annotator, and rather than giving it to human annotator, we give it to OpenAI or open source LLMs to generate a lot of fake data, which actually is defensive, argumentative, or rude. Similarly, we defined a rubric of what is like top 5 tone. Somebody has to be patient, solution-oriented, respectful, and we generated a lot of like artificial data first of like being a customer service agent, what it looks like. The main idea of not going first to real time, real data versus relying on artificial data at model V0 was that, like, if we use real data, often much of the data is lying on that borderline where it can be either side, versus this gives a contrasting contrasting examples to like the supervised model that, okay, that is definitely rude and that is definitely, respectful and stuff like that. And that's how, and then we went to adding then when we had the V0 model, and then we added the real examples to improve the model. Here are a few examples which I gathered from how the model is performing, like argumentative. I don't think you understand how our product works. Defensive, maybe you are the first one who is seeing this problem. I've never seen this problem before. Rude, you're just going to have figure out yourself. Mocking, I can't believe. Negative, and actually, let me talk about the detection rates. Like, when even I was first developing this, I thought like no one speaks like that. But among the millions of chats, most of these have at least like 0.5% detection rate, which is like thousands of chat among like hundreds of millions. Like agents actually speak like that. So yeah, that was very good to like, rather than like having a QA mechanism which we had, like dinging the agent score after the fact, like this could actually help the agent to be a little bit more empathetic and perform better. And this is a real example of a top 5 tone that, okay, I'm closing the chat for now, and feel free to open it back and I'll be happy to help you. So one part which is I did not include it here is that once we have a detection rate of say 0.5 of each one of them, and combining maybe it's around like 2.5%, we use open source LLMs to improve the tone. But again, we have to be very, very careful. Is that like we cannot like rephrase, because once we rephrased, a lot of meaning is lost, and that was something like a no-go from product. We need to keep the original intent. So one of the challenges was that, like, keeping the information same, but also like improving the tone or overall language. Sometimes it's even possible, and sometimes even LLMs might say that this is against the policy or stuff like that. So that is continuously like an evolving product, evolving feature. Like how do we enhance the tone? But that's what we delivered as like a beta product first. The another feature which we implemented was like using a lot of like filler words, and right from the beginning it was like very hard even for us to understand like from a conversational AI perspective, what does the filler means. Again, there was a dearth of open source available data for filler utterances. So again, we used open source LLMs and OpenAI models to generate a lot of like utterances which had filler words, and then generating contrastive examples which were not having these filler examples, and then training a supervised model, again iterating to like real chat data, and then feeding back to the model to improve the model performance. And then the next steps were obviously like to improve the latency for real-time deployment and usage of multilingual embeddings. So these examples are actually coming from LLM and this is fake data, that that's filler and that's not filler. And when that went into production, it's actually like catching a real agent utterance, which actually had like words which could have been eliminated, simplifying the sentence, but still retaining the meaning. Again, the detection rate of this was somewhere around like 3 to 4%. So yeah, we like overall, like in real time, if you're helping agents to write better or write simplified utterances, which improves the overall communication, that would be super helpful. Relevance. This was the hardest piece, because relevance, as I said, like when someone asked me a question and at the end I said, did I answer your question properly? That's what the relevance is all about. Because oftentimes when agents talk, there might be like communication break, because we don't know whether the other person is still there or listening to us. So we can say, are you still listening? Are you still there? seems like we have a communication issue. On the other side, there might be cases where there are a lot of like small talk happens, like how are you and stuff like that. But we might be digressing from the original question, and that might like delay the overall like issue resolution what customer is looking for. And now, so that's one. The second piece is that when we say relevance here in this particular feature, it is not meant to be like from knowledge perspective, because for that we need to have some sort of a retrieval augmented generation where we are backing it up with, and that is a separate feature actually altogether, that backing it up with knowledge articles and previous closed chats and finding out the ground truth and answering them. Versus this was like something like quick and dirty, like language-based relevance, that given the language, given the problem which like user is trying to pose, and given what I'm saying, at least from language, not knowledge perspective, whether it's like aligning or not, and that's how we were thought of like giving like sort of like a relevance score of 1 to 10, and then kind of like flagging the agent that he should be giving the answers which are a little bit more relevant. Again, there was no publicly available data set available for training. Human annotations in the past, they have taken a long time, and then the product roadmap we were given, we didn't have so much time to go through human annotators and annotate the data. So again, we used AI to generate a lot of data so that we can train these large language models. So the step one was like taking a lot of examples of relevant chats, irrelevant chats, giving a few short examples to an LLM, and went and flagging a lot of like real customer data, and then using some man in the loop product teams, QA teams, annotators to make sure that like whenever we are giving the score of like 1 to 10, it's actually aligning with like human judgment to a certain extent. And this was very hard because there's so much discrepancy even between like a turbo model or a GPT-4 model or an open source model. But so that was the hardest piece of like establishing the ground truth. But once that's done, the step two was actually to like take that ground truth data where we have like a user utterance and then customer utterance, and then fine tune that on a score of like 1 to 10, and then having this model ready for production. And again, one of the challenges was that since we are using like a 1 billion or a 7 billion model, how do we reduce the inference time for a real-time production? So I'll just walk you through with a very small example where a user is saying like, I need help with targeted messages. And if agent says, are you still connected? And this happens actually more than 20 to 30% of the time. And this is actually the problem we deal, that we need to discard this data for our other features, because otherwise, like the autocomplete features try to learn this and try to answer in this way. But regardless, since the scope was, regardless the situation which the agent is facing, at least from the language perspective, yeah, this is irrelevant, completely irrelevant. And this response is actually coming from an LLM, that agent response that does not assist the user in creating a target message. So it's like completely irrelevant. Versus how can I create a target message? An agent comes up with this. Now this may or may not be a ground truth, because this is not RAG. This is not powered with RAG. But still, from language perspective, it looks very relevant. And that was the entire intention of developing this feature, that at least from language perspective, we are able to check or help or flag an agent that, okay, he's going in the right direction or not. Sentence shortening was a big piece, because often agents might be in a real time, might be writing a very long sentence because they don't have time to like think it through. On the other cases, when we are writing an email or a thesis or a paper, we have a lot more time than these agents do. So the whole idea was to do a sentence contraction. But again, the biggest challenge was like, although we are simplifying, we cannot take the meaning away. So this was not a rephrase. This is just like strictly like shortening the sentence. And this is one example of a long-ish sentence. And then this is like the shortened sentence using an LLM. Like omitting certain words and maybe adding one or two words, but keeping the meaning intact. And that's how like giving a much simplified communication to an end user. The first part was detection, which was very easy that we can define like a word limit, but the second part, took some training and development. Grammar correction. So we started with an open source model from Grammarly from Hugging Face, and actually I read your paper, Vipul, and and that's how we started. And this is and actually we were lucky to got like a 700 million model, which was kind of like fitting to our latency spec. The improvements are still in progress, but now we are taking it forward to like top 7 languages, and most of them are Western European languages. And the idea is same, that when I at least looked online, there were not too many like open source ground truths type data available for good and bad grammar outside of English, at least what I looked. And so the idea is that going back on, like we develop all previous features, like developing like 150 to 200,000 this like good grammar and bad grammar pairs using a large language model, giving it back to T5 and then train it. Abuse, I will say, was the easiest because there's ton of data thanks to social media that we can train a supervised model and have a probability and predict. Although this happens very less, but like our PMs wanted to have a guardrails around whenever this happens. In the end, we were getting continuous feedback from engineers who is testing it that they feel sorry for the agents who will be using it because like every time you're typing something in real time and you're in a rush to hit an enter and you see all of these pop-outs, how do we improve that journey? This is just one attempt. This is still work in progress, and the idea is that like we can fix all or ignore all, like trying to minimize the number of clicks. But yeah, this is like still work in progress. And with that, I'm happy to answer any questions you have.
Technically challenged today. Thank you for the talk, and yeah, it's really cool to see you using the data sets and models we released.
Yeah.
I had a couple of questions. You mentioned synthetic data generation. Yes, it's been around like for a while, but I'm curious, how did you validate or maybe measure data set diversity? Or it's real world customer data will have certain distributions, but data that's generated strictly from these LLMs would be very different in terms of its distribution. So how did you, did you consider doing that, or like did you look into that?
But yeah, obviously, so in real life, this detection rate might be like 0.2%, 0.3%, but training a supervised model, actually, what I found like over time is that at step 0, if we don't mix up with real life examples, because although they might be rude, but they might be borderline rude, using this like contrastively like different examples which a fake data might give you gives a very good V0. But then it's an iterative, distribution is important, and in certain cases actually we are doing that. So for grammar, we are seeing like 30% of the utterances go through grammar correction. So when we are building our multilingual grammar, we are taking that into account. So we will maintain that 70-30 ratio. But in many of the cases, like 0.2, 0.5, it's very hard to maintain that ratio and build a good classifier around it. And regarding the evaluation, it's still going through manual, like UA teams are like testing these out, PMs.
Right.
Because it's so new, it's hard to establish like what's the ground truth. Like we can give it to GPT-4 or any other human annotator, but
yeah.
But like stuff like relevance and tone, they are like always debatable. There's hardly to get an agreement around it.
Right.
Grammar is actually still very straightforward. It's like it is what it is and stuff like that.
Most objective of all the tasks.
Right.
Yeah. One more follow-up. You mentioned tones. How many tones were there did you work on? Like, what's the, let's say, label space?
Yeah, so basically it was like overly scripted robotic.
I see.
And that is really important because that might be coming from canned response, because that's what one of the features we built, that okay, give this canned response and help agents answer, but then we have to develop like a detailed rubric around it, that okay, what is a canned response, what is like overly scripted or robotic, and then it was like argumentative, defensive, rude, especially like this rude, sarcastic, argumentative. They were like very common.
Yeah.
Negative was very hard to crack down upon, because sometimes a person might say this might be a real issue, and that's where this was like a continuous like iterative process. The next step would be to having something like RLHF or some sort of like reinforcement learning based method. But right now it's all like manual evaluation and then enriching the training data set until we find the right amount of precision in these models that which is shippable.
All right. Thank you.
Thanks.